Coming around with periodic tables. Go on periodic tables.
Okay, let's settle down. Okay, so if you remember, monatomic ions have how many atoms in them? Monatomic, one atom. So now we're going to be looking at polyatomic. What does poly mean? Poly means many. And then atomic obviously is atoms. So what we are looking at two or more atoms. They will actually be covalently bonded together. You're not responsible for knowing that part. Okay, but if you look at it, this looks a lot like a molecule, yes? The only thing that's different is that it has an overall charge. So it looks like a molecule, but it has an overall charge. So for example, this one's name is nitrate. Okay? Anytime you see the ending 8, the ending 8 tells you it's a polyatomic ion. Okay, you will never find a nitrate anywhere other than on, and if you look on your green sheet, let's look under N. So on your green sheet, you'll see at the top, we have positive ions. How many of those are there? Just 2. And they are very often forgotten by students. Okay? So look out for them. Look out for them. Negative ions, we have them listed alphabetical by name. Okay, so you can see we've got acetate, carbonate, chlorate, all are A, B, C, D, E, H, I, M, N, O, P, S, T, okay? Then we have alphabetical by formula. So if we want to look up NO3, I would go down to this list where I have alphabetical by formula, and I would say, well, N comes after H. So here are my H's. Okay, so I got to keep going down until I get to NO3. Okay, and that tells me that its name is nitrate. And if you look at all of the names on here, how many 8s do we have? A lot. We've got acetate, chlorate, perchlorate, carbonate, chromate, oxalate, dichromate, hydrogen carbonate. Ooh, I want you to circle or highlight or underline this little or, because those guys have 2 different names they can use. So if you're looking for B's, just remember that if you're looking for B's, you can find them here, okay? Bicarbonate, binoxalate. We got monohydrogen phosphate, carbonate, carbonate, 8, 8, 8, 8, 8, 8, 8, 8. And then over here we have 8, 8, 8, 8, 8, 8, 8. So the majority of polyatomic ions end in 8. Their name ends in 8. What's another common ending? Ite. We've got ite, 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 ite. Oh, we got some more ors over here. So let's circle our ors. Or. Okay. Any more ites? Yeah, we got some ites over here. Ite. And that's it. Okay. Let's take a look at these for right here. We got ClO, ClO2, ClO3, ClO4. What is the difference between each of those ions? Tell your partner, what is different about each of those ions, those 4? We have different subscripts for oxygen, which means we have different number of oxygen atoms. Okay, so that you don't really need to know this. All you need to be able to do is use this table and look things up. But if you are interested, the 8 ending, that's the most common. Ites. Well, how would you compare the number of oxygens in an ite compared to an 8? There's 1 less oxygen in ite. 1 less oxygen in ite. Then we have hypoite. How does that compare to our ite? Yes? 1 less. 1 less than ite. Now, what if we have a per 8? How does that compare to our most common ion? One more. Do you need to know this? No. Do you need to be able to look them up? Yes. But if you're interested in that kind of thing, you can find patterns. See if you can find another 8 and ite on that table that show the same pattern. So once you've written all that down, see if you can find another 8 and ite that follow that same pattern. And you can just give me a little wave if you found it. You're not committing to telling me anything, but if you found it, give me a little wave. Got one over there. Good, good, got it. Yeah, yeah. Got about 6 people who found it so far. Keep looking. Another one. Excellent. Yeah. We are looking for another ite and 8 that show that same kind of pattern. Yeah, we got it over there. Yeah, all right. Okay. All right, if you still haven't found it, that's okay, don't worry. We have nitrite and nitrate. Nitrate is the most common. Nitrite has 1 less oxygen than nitrate. Okay? So you have to be, chemistry can be really picky. Okay? If you write a 2 when you mean a 3, then you're writing something totally different. Yeah? If you write nitrate instead of nitrite, you mean something totally different. And again, what if I, instead of nitrate or nitrite, what if I did nitride? What would nitride be? What would the formula for nitride be? Yes?
N negative.
N negative. And because it's in group 15, it would be N3 negative. So anytime you see an ide, it's usually monatomic. Okay, so an ide, usually monatomic, which means you're not going to find it on your table of polyatomic ions. Nitride isn't on here because this is just for polyatomic ions, whereas this is just an N with a 3 minus, a single atom. Yeah? There are a couple exceptions. There are 3 ides. 3 ides. See if you can find the 3 ides that are polyatomic. Very nice, Ryan. You got him, Max. Excellent. Spencer, nice. Got it, Mateo. Very nice. Got it, Malia. Awesome. Got it, Miriam. Very nice. Got it? Yeah? Okay, very nice, very nice. Okay, so one of them is staring me in the face. Which one is that? Hydroxide. I got hydroxide staring me in the face. So hydroxide, watch out for this one because people see hydroxide and they try and make it hydrogen, but it's got an ox in it. So it's both hydrogen and oxygen. Okay, that's different than hydride, which is just hydrogen. Okay, so hydroxide is one of them. We have hydrogen sulfide or bisulfide. And there's one more, cyanide, which I don't know. Do you guys know anything about cyanide? It's a deadly poison, yes. I grew up reading lots of Agatha Christie. Are you familiar with her as an author? She writes lots of mysteries, and if you ever want to improve your vocabulary, read her stuff, because I read her books, and I'm like, I don't know that word, right? It's like, plus you just get to read a fun, like, they're such cozy mysteries. They're so good. Like, whenever I'm feeling like down or anxious or something, I'll read myself a nice Agatha Christie, and it's one of those cozy mysteries that makes me feel calm and relaxed. I don't know why. Why does watching true crime make people feel calm and relaxed? I don't know, but it does. Anyway, it's a lot like that. So Agatha Christie, awesome author. She will build your vocabulary, especially if you have like an ebook or something like that where you can like look up the word immediately. That's really nice. If not, you can just, look it up in a dictionary on your phone or whatever. So most of our polyatomic ions are 8s or ites. There are 3 ides, but all the other ides are monatomic. Okay? And we will go back to here. There we go. These guys, these polyatomic ions, behave like a single species. In fact, they are a single species. They are a single particle. Okay? Just ignore this part about ammonium. I think it's confusing. Just ignore this. Okay? But when you are balancing out charges, because remember, what charge are compounds? Compounds are neutral. Magnesium is in group 2. If it's in group 2, what is its charge? Magnesium is 2 plus, or plus 2. So if you know that magnesium is 2 plus, how many NO3 minus 1s do you need to go with it? You need 2 of them, NO3 minus. So what that's going to look like is it's going to look like that, where we have 1 magnesium and 2 nitrates. Now, we don't write it like this, because that's not how we write chemical formulas. What we do is we say that we have 1 Mg. What do we put beside the Mg if there's 1 of them? Nothing, right? Nothing. Now, nitrate, NO3, we need to somehow show that we have 2 of them. Normally, we would just put a little 2 down at the bottom, but if we were to do that right now, it would end up looking like MgNO32. Is that good? No. So what we do is with polyatomic ions, if we have more than 1 of them, we put them inside brackets. This too, it's like when you use brackets in math. Something on the outside of the brackets multiplies everything on the inside of the brackets. I have not left enough room for writing. That's terrible, but oh well. So that is the correct formula for MgNO32. And later on, you will be going from the name magnesium nitrate to the formula, and you'll be using this kind of method where you balance the charges out and make everything equal out to 0. But right now, I'm going to give you that thing. I'm going to give you that formula and make you write the name. And all you're going to do is you're going to look up Mg, and you're going to be, oh, Mg is magnesium. Is magnesium in the red zone? Magnesium. No, it is not. So do you use a Roman numeral? No. And then all you do is you look up NO3 on your polyatomic ion table and you say, NO3, what's its name? Nitrate. So you just name this magnesium nitrate and that is it. Easy? Okay, if magnesium was in the red zone, you would have to find its Roman numeral. Okay, but that's really all there is to these. Okay? We're just going to do a little bit of this because otherwise it can get kind of boring. But we're going to meet a few of the polyatomic ions. This is one of our positive polyatomic ions. Its name is ammonium. Not ammonia. If you remember, ammonia What was the formula for ammonia? Ammonia was NH3. Okay? Ammonium is NH4 plus. Ammonium is an ion. So what type of compounds would we find ammonium in? Would we find them in covalent compounds or ionic compounds? We would find them in ionic compounds because it is an ion. It is a what type of ion? Anion or cation? It is a cation. Does the cation go first or second? Cation goes first. Okay? So I don't know if you remember, but on our naming compounds flowchart, do you remember? Ionic compounds start with a metal or they start with NH4, right? Because those are our cations. So ionic compounds start with a metal or NH4. Let's go back to our other page there. So sorry. Okay, so your cation is either going to be a metal or it's going to be NH4. And that's how you know it's ionic. If it does not start with a metal, if it does not start with NH4, it is covalent. Okay? So if you're like, is it ionic? Is it covalent? Is there a metal? No. Is it NH4? No. Then it's covalent. So anything that does not start with a metal or NH4 is covalent. Here is ammonium chloride, and you can see what kind of a structure does it form? It forms an ionic crystal lattice where we have positive, negative, positive, negative, positive. Oh, whoops. Negative, positive, negative, positive. But you see the positives are these little groups. They're those little polyatomic ions. Okay? And now that we get the general hang of it, we're actually going to skip the rest of this one, and we are going to go to page 47. And on page 47, we are looking at ionic compounds with polyatomic ions. It's not terribly important that you learn this, but if you have a binary compound, how many elements is it made of? 2. If you have a ternary compound, can you guess how many elements it's made of? It's made of 3 or more elements. Page 47. So if you got a binary compound, it's really easy. Your cation is going to be a metal. But if we have a ternary compound, the cation can either be a metal or what's the other thing it can be? It can be a polyatomic ion. And that polyatomic ion, what is the only one that matters that's not a metal? NH4. And if you're doing the enriched, you should pay attention to Hg2, 2+. We'll talk more about that later, but that is enriched only because it's kind of weird. You remember how mercury was kind of weird before? Why was mercury weird before? Because it's a metal, but it's a liquid. Okay, so mercury is kind of weird in that sense, but it's also kind of weird here. And like I said, we'll talk about that later if you're interested in the enriched part. Now, anions. If we are in a binary compound, the anion is a nonmetal ion. If we're in a ternary compound, we can either have the anion be a nonmetal or what else can it be? It could be a polyatomic ion. And for the polyatomic anions, there are like lots of them. Do you remember that whole list we just went through? We just looked at them all your 8s and your 8s and your all of those. So many of them. When we named binary ionic compounds, we just named them. Okay, we said sodium, chloride, manganese. Oh, manganese is in the red zone, so we need a Roman numeral oxide. Yes? These should be very familiar to you by now, or at least getting that way. Iron is in the red zone, so it needs a Roman numeral. Calcium, not in the red zone, so no Roman numeral. Okay, and all those endings of those elements all changed to "ide." But I think these ones are even easier because you just name the cation like you did before. These are our ternary ones. Okay, these are the ones with polyatomic ions. PAIs, can we call polyatomic ions PAIs? Name the cation. It's either the metal or ammonium. You use the same rules as before. Ammonium never has a Roman numeral. Why not? It's not even on the periodic table, let alone in the red zone. Yeah? Okay, in order to have a Roman numeral, you need to be on the periodic table and you need to be in the red zone. Okay. And it's only going to be metals. So, and then we name our anion. So we name the cation, we name the anion. If it's a single element, we do like we did before. So here we have NH4, and that is our positive ion. And then we have Cl, and that is our negative ion. NH4 is ammonium. Cl is chlorine, but when we put it in the compound, its ending changes to ide. Here we have Mn. Mn stands for manganese. How many Mn's do we have here? How many Mn's? Look right there. We just have one. So we have Mn. Is Mn in the red zone? Yes, it is. So it needs a Roman numeral. How do we find Roman numerals? We write out all the ions. So we've written out our 1Mn. How many carbonates do we have? We have 2 of them. So we write out CO3 and CO3. What's the charge of CO3? Go look it up on your polyatomic ion chart. CO3. CO3, what is its charge? 2 negative. So we got a 2 negative and a 2 negative. What do we do with all those negative charges? We add them all up to get a total negative charge of 4 minus, or negative 4. What does the entire compound have to equal? It has to be neutral, so it needs to equal 0. So what does the total positive charge have to be? It has to be 4 plus, and there's only one atom there, so what is the charge of that manganese? 4 plus. So this guy is going to be manganese 4. Do you guys remember the Roman numeral 4? 1 before 5. Okay, let's take a look over here at our Fe. Is Fe in the red zone? Is Fe in the red zone? Yes. So if it's in the red zone, we need to figure out its Roman numeral. So we start by writing 1 Fe. How many CNs are we going to write? We're going to write 3 of them. And you'll notice, hey, the CN is in brackets because we need to multiply both the C and the N by 3. We don't just have 3 N's and 1 C. We have 3 N's and we have 3 C's. So we have CN, CN, CN. What is the charge of CN? Look on your chart. Minus 1. Minus 1, minus 1, minus 1. What do we do with all those minus 1s? We add them up and we get minus 3. The whole thing needs to equal 0. So what does our positive have to be? Plus 3. That tells us that this single iron here is plus 3. So what's the Roman numeral? 3. Okay, so our 3 here is our 3 here. Our last one, we've got Ca is calcium. That's our positive ion. As soon as you hit the end of the positive ion, everything else is the negative ion. I don't care how long it is. Everything else is the negative ion. You're never going to have 3 ions. Don't try and give anything 3 names. Okay? They're only going to have like cation name, anion name. 1 name, 2 names. First name, last name. Okay? We know that Ca is calcium. That's pretty straightforward. Please go look up CO3. CO3 is carbonate. So we just name it carbonate. And because is calcium in the red zone? No. If it's not in the red zone, life becomes really easy. You just say calcium carbonate and you're done. We're actually going to just practice finding the cation and the anion because that's one of the skills that people find difficult. You will only ever have one cation and one anion. So what you do is you look for your first capital letter. That is going to be your cation. Unless your cation is NH4, in which case all of NH4 is your cation. What that means is that everything else is the anion. How many capital letters here in the PO4? 2 capitals. Therefore, it is a polyatomic ion. Okay. So we got our positive ion, we've got our negative ion. We've got our positive ion, NH4, we've got our negative ion. We got a metal, and then everything else is the anion. Metal, everything else is the anion. NH4, everything else is the anion. NH4, everything else is the anion. None of these have Roman numerals, so these are all really easy to name. This would be, who is K? Potassium. You look up NO2. NO2 is nitrite, so it's just potassium nitrate. Yeah? Mg, magnesium. ClO3 is chlorate, so just magnesium chlorate. Remember, 2 names, only 2 names. So what I'm going to get you guys to do now, you're not naming these. You're just saying who is the cation and who is the anion. Remember, everything after the cation is the anion. I don't care how long it is. It can be super long. Okay, identify your cation. Everything else after it is the anion. Okay, so this is on page 49. So do those.
Oh, I see it. We haven't even started. Bro, I think it's cancer too. Five. You guys are like so like I don't know like every 2 minutes. Okay, I feel like it's my last one.
Wait, when are we gonna get a test? What is that?
Yeah. Okay. You're playing if it's in the red zone. It's let's see what ones it means. Oh, we had a snape in the they're not ships. So how many? We aren't crazy. No, it's we have to like ready. No, we have like all kinds of actually. Could probably. No, one time we have done shift before. We have done shift before. But this one is actually down. It's so no, we should like play it. It's so warm slide on your face. And it's even better that nobody knows how to like I want to slide. We have Polly and BQ. Murder wonderful wonderful. Oh yeah, that was really good. It's Jack. Oh look. Okay, basically, Jack, I'm trying to forgot. Yeah. Yeah. We have a bunch of Jack. I'm pretty sure. Yeah, I was in the middle. No, I've seen it. That one was crazy. That was a little weird. That one's a little weird. Who wrote this? Oh yeah, James. How did that know? No, bro. No. Again.
Okay, folks. I've actually skipped one section. And the reason I skipped that section is because once you have done the little positive negative thing, all you do for these ones, which are on page, where is it? Page 51, you just name them. This page 51 has no Roman numerals. There's no red zone in here. And all you would do is you would say, what's the name of BA? Barium. What's the name of the rest of it? Cyanide. Okay, so you would have to look on your table of polyatomic ions. You got your positive ion. What's the name of K? Potassium. What's the name of SO4? Where would you look for that? Polyatomic ion chart, and that is sulfate. What's the name of Na? Sodium. And then everything else, HSO4, we go here and we're like, what is HSO4? Now, it is one of the ones that has the little or. You get to choose either hydrogen sulfate or bisulfate. Do not write both. Do not write both. Or was it SO3? Oh, I'm sorry. Yeah, if it's SO3, then it's sulfite. Oh yeah, it's SO3. So this is either going to have the name sodium, hydrogen, sulfite, or it's going to have the name sodium bisulfite. But what I don't want to see is sodium hydrogen sulfate bisulfate, or hydrogen sulfite bisulfite. I don't want to see both names because that's crazy. All right, it would be like, you know, if we had a name like, let's just say Matthew. Matthew goes by Matthew, but let's pretend that sometimes he went by Matt. Do you ever go by Matt? Sometimes, okay. But would it be weird for someone to come up to you and go, hey, Matthew, Matt? Would that be weird? And you'd look at them like, what is wrong with you? That's what would happen if you gave this thing the two different names at once. Okay? You only call someone by one of their names, right? You don't call them by both versions. Okay? What about this next one? Who is the cation? NH4. So that is ammonium. What about ClO3? That is chlorate. Okie dokie? So that's how you do those ones. That's page 51. If you feel you need practice with that, go for it. If you feel like those ones are straightforward enough, then we are very quickly going to take a look at finding the Roman numeral. Yes, Logan? We're going to take a look at finding the Roman numeral. So pay attention to this part because you wanted that, right? So we are going to go to page 52. We find the Roman numerals exactly like we did before, but I think lots of people since last week have forgotten how to do that, so we're going to learn it again, okay? So if you've forgotten how to find Roman numerals, this is how you do it. So the first thing you do is if you have SN NO32, what that's really going to look like, just so you can visualize it, is that you would have an SN, monatomic ion, and then you would have two NO3s, right? We have one SN, and we have two NO3s, two groups of NO3. So what we're going to do is we're going to write out all our ions. We're going to write out one SN, and then we're going to write out two NO3s. Second thing we do is we look up the... Logan, are you paying attention? This is what you wanted. Right. What's the charge of the NO3? Where would you look to find that? you're going to look on the green sheet. And you're going to find the charge. What's the charge? -1 and -1. Once you've got those two negative charges, what are you going to do with them? You're going to add them up. So -1 and -1 is -2. Then you say, what is every compound equal to in terms of its overall charge? It's always equal to 0. So I need to have, from my positive ion, enough charge that when I add it to my negative charge, I get 0. What do I need to have in terms of positive charge? +2, which means that this tin is going to be +2. So tin is in the red zone, so we're going to call it tin 2. And then we name NO3 by looking up its name on the green sheet, nitrate. So far, so good? Okay, we're going to do an example where we don't just have one of the cation. It's easy when there's just one of the cation. This 2 all goes right there. Okay, tin 2 nitrate, blah, 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 blah. Next page. Ooh, this one's actually also really tricky. This is where you could go wrong. Okay, so watch out for this. We have Fe and we have PO4. We're going to write out all the ions. I'm going to give you two choices. We can do the following in red. Fe, PO, 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 PO. Or in black, Fe, PO4. Which of those is correct? Is the red correct or is the black correct? The black is correct. There's no brackets around the PO. Yeah? This would be FePO4. Does that make sense? And you can actually see the picture. We have an Fe and then we have a P with 4 O's attached. Yeah? So we just have one of them. So now that we've written those out, we need to look up the charge. What is the charge of PO4? Charge of PO4 is -3, 3 minus. So my total negative charge is -3. That needs to equal 0. What's the total positive charge? +3. And we've only got one place to put it, so what's going to be the charge of the iron? 3 plus. So we will name this iron 3, and then we look up the name of PO4 on the green sheet, that is phosphate. One more example, then I'm going to set you free to do your thing and get your test back to you as well. Shh. If there are no brackets, there's only one of the polyatomic ion. So don't try and give me 4 if there's only one. Okay? No brackets, only one. No brackets, only 1. I only have 1 if I have no brackets. No brackets means only 1. What does no brackets mean? Only 1. Okay. Let us try Cu2SO4. I'm going to give you 2 choices here. Cu, or Cu, Which of those is correct? Is it the red or is it the black? Red. Because the black, you've got no brackets. So you have only 1. Look up the charge of the sulfate. What's the charge of the sulfate? Sulfate is 2 minus. That means my total negative charge is 2 minus. Total positive is 2 plus. Does that mean that my compound is copper 2 sulfate? Is that correct? If you've lost your attention, bring it back. Is this correct? No, why not? Because each copper has to have a +1 to add up to 2 plus. So it's not copper 2, it is copper 1 sulfate. Okay? So what I would recommend that you do at this point is that if you're kind of like not getting this, you could save it till tomorrow and then work on it while I'm here to help you. And you could work on page 51 if you want to. But if you would like to, you could work on, what happened here? 54. You could work on pages 50. I've lost my pages. They didn't get printed out. That's irritating. Pages 55, 56, and 57. So I'm going to recommend that you guys do pages 56 and 57, and that should get you ready to do quiz number 5 tomorrow if you get it. If you don't get it, that's okay. We can go over it tomorrow, okay? This will prepare you. I will check your homework. If you find that's too much, if you're like, oh my God, so much, do every other question. Yes? You can do every other question if you want to.
I think it's 6, 7 on one.
I've seen it before, but I didn't. So like you looked at the.
Yes, I did. So Maya and Emily. Let's write those down.
Oh my god, yeah, it's beautiful Friday.
They have to do a test, yeah, Thursday this week
Oh, Maya. Sorry, what's that?
for the self-paced test. They have to do a test until
Who?
self-paced unit.
Oh, yeah.
Do a test until Thursday, right?
I don't know. What?
Yeah, what's the test?
I haven't announced a test on this one yet. Where did
No,
you get?
like they have to complete the test on Friday or not. So I haven't told anyone.
Oh, I don't know. I didn't know that. I don't remember telling you that.
Okay,
So, I don't know.
it's okay.
Emily. Okay, hi.
Am I allowed to see what?
In a minute. I gotta mark this down. I know. You did so good.
Yeah.
Just give me a minute. I gotta write down Spencer's grade. Spencer. 6. And Ken. Ken. Oh, quiz 6. Okay. Carbon dioxide, dimethyl peroxide, nitrogen monophosphide, iron chloride, diphosphorus pentoxide, and carbon tetraiodide. Did you get that after Spencer, please? Okay. Okay, folks, I'm going to give you back your tests. So we don't have a lot of time, so if you want to look at it more tomorrow, you can look at it more tomorrow, but I will get them back to you today. Let's start with Spencer and Amaya, Varuni, Ryan,
Yeah.
Vivian,
Sure.
Oh, yeah.
Here.
I don't know why I called you Vivian today. I got excited about that. Sounding very French. Let's see.
It's okay, I don't know.
Spencer, Jordan, Paul, Samaya,
Out of 40.
Oh,
Samaya. Okay, very nice. Mateo, Hernan, Kira Austin, Zoe's son, Valerie, Miriam, Malia, Emily,
Okay.
Laura, Emily, Max, Ken, Sue, Jennifer, Logan, Zoe Watts, Jennifer, Matthew, Cody, Sophia, Hi. Oh, you know what? I think I added them on. Did I add them on? Take a look on the front page.
okay, maybe it's,
Yes. Yeah. Yes. Hi. I haven't given everyone a progress report because I didn't get them in. But what I will do is I will find them right now and I will give out the rest of them. I also have progress reports. Ken,
I don't need this.
Cody, Jennifer, Ken, progress report, Jennifer, Logan. How did I do that? Logan.
Different words.
What? Oh. Oh, that's Cody's. Sorry. Logan. Cody. Max.
Oh, yeah.
Max. Cody. Malia. Hudson's not here. Matthew.
Wait, was this for this? I thought I got 90. This is Oh. Oh, it just said test quiz. It just said
That's
test.
all tests all together.
Sorry, I thought we were
Oh,
gonna
that's
take it home,
good.
so I
That's okay. Matthew. Vivian. Matthew. Emily, please bring your test back once you have looked at it. Vivian, Emily, Mariam, Zoe's son,
Wait, with this?
Sue.
With the.
Yeah. Sue, I gave you the wrong one. There you go. Laura, Valerie, Zoe Watts.
Oh, I got this. Let's keep this.
Yes, you keep the progress report. Zoe Watts, Laura, Sophia, Laura. Hi.
Wait, you.
Woo! Okay, I need to change that for you. Okay, must have been a typo. I'm so sorry, Sophia and Laura. Oh yeah, typo. Yes, please. Hand your test back
tell
in.
you, but can I redo this one, the ionic bonding? I think I forgot.
Yeah, for sure.
I forgot to redo it.
Yeah, do you want to do it like small flex? Yeah. Okay. If you do find yes, if you find a mistake with your mark, let me know.
I know I fixed this one up for sure. I fixed it.
Okay, let's see.
So I don't.
Let's see.
The quizzes.
Okay. It's possible I've not updated them. Logan. Yes, no, I remember that. Let's make sure. Hang on. Can you go and slide that little lever that's above the light? There's a little, no. Do you see the light? Go right above it. Slide. Perfect.
There we go.
Awesome.